Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Class 10th subject physics, unit number 11, sound, and today is our topic sound intensity level. Here today is our topic sound intensity level. So, human ears respond to the intensity ranging from 10 की power minus 12 watt per meter square to more than 1 watt meter per minus square, which is loud enough to be painful. Because the range is so wide, intensities are scaled by the factor of 10. The barely audible and the faintest intensity of sound is 10 की power minus 12 watt per meter square. Is taken as a reference intensity called a zero bell, which is a unit named after Alexander Graham Bell. So, by these conditions, we come to know that the loudness of a sound depends not only the intensity of sound but also on the physical condition of the ear. The human ear is more sensitive to some frequencies than the others. There are the simple examples. We can see that a little boy can hear a more accurately than a aged person because they have a both have a different physical conditions of ear. So today we will explain our topic by the derivations. Okay. The loudness of the L of the sound is directly proportional to the logarithm of intensities. So we can write like this: directly proportional to log intensities. So proportionality sign will be replaced by a constant, and that constant is a k log I. Here k is the proportionality constant of proportionality. So now let's suppose L not be the here L not be the loudness of the faintest audible sound of intensity I naught, and L be the loudness of a unknown sound of intensity I naught. Here L naught, that is the audible sound intensity, and I naught and the L be the loudness of a unknown sound of intensity I. So the first equation can be written in the form of L naught is the loudness of a unknown sound and K as it log I naught, that is the audible sound. Here it can be written like this: log. Clear? Now by subtracting we have two equations. One is this and one is this, second is this. So by subtracting both equations, L minus L naught, that is equal to K into log I minus log I naught. So this equation can be written in the form of, we know that when the log, there are a log in that form, it can be changed in the deviant form. That is a rule. In maths there are a fourth law or third law. So we can say that the difference L minus L naught between the loudness of L of an unknown sound and the loudness L naught is called the intensity level of a unknown sound. Therefore the intensity level of an unknown sound is given by level K log I over I naught. That is the intensity level for the unknown sound. Now the value of K depends not only the units of I and I naught but also on the unit of intensity level. If intensity of an unknown sound is 10 times greater than the intensity of I naught of the faintest audible sound, then it can be written like this: intensity of audible sound is equal to 10 times of a unknown sound intensity is equal to 10 times of a intensity of a audible sound. And the intensity level of a such a sound is called taken as a unit called a bell. The value of k becomes 1 in equation number 3 here, that is equation number 3. Putting the value, we will get the relation intensity level that is equal to 1. So log I over I naught, and bell is the unit. So bell is a very large unit of a intensity level of a sound. Generally a small unit called a decibel is used. Decibel is abbreviated dB. So bell is a large unit, and smaller unit of bell is decibel, and decibel is abbreviated as a dB. It must be remembered that 1 bell is equal to 10 decibel. Clear? Now if the intensity level is measured in the decibel, then the last previous one intensity level, it can be written in the form of 10 log I over I naught decibel. So by using this equation we construct a scale of measuring the intensity level of sound. Such a scale is known as a decibel scale. The intensity level of this of us any sound is can be found by this formula. This is our topic. Here is a useful information. A sound wave with a frequency of 3500 Hz and an intensity of 80 decibels sounds about twice as loud to us as a sound of 125 Hz and 80 decibel. It is because our ear are more sensitive to the 3500 Hz sound than to the 125 Hz. Therefore, intensity by itself does not mean loudness. Loudness is low, how our ears detect and our brain perceives the intensity of sound waves.